Hey, I'm Sarah. Today it's time for part 3 of my BLE Scanner App. So I'm here in Windows and I'm using Miracast to cast my physical device. So today I'm going to demo the updates that I've made since the last video. So let me go ahead and open my Scanner App, and this is going to scan all of the BLE devices that I have in my home. And first, let me show you my LED light strip. So we go in here and we connect, and I'm listing the device name up top here, whether or not it's connected, and we've got the MAC address and the timestamp of when it was last scanned. And here in my service pager, I'm listing the main service, and then underneath it, I have the characteristics for each service. So here, I can go ahead and click Read, and it comes back, and for the user, I'm providing several different options because we never know for each characteristic, it can be different on how you actually process the bytes. So here we actually have a string that comes back, and I have the hex string, the byte array, and the binary code. And now for appearance, this is cool. For this characteristic, the byte array is a little bit different. Here we can parse it and actually read the category, the subcategory, and the value. So let me go ahead and click Next. And here, this lists the manufacturer service, and we've got a custom UUID here. So we can read data from this. And the cool thing is you can also write data to this. So here, I've looked up the manufacturer specs and I found a few keys. So to actually turn my lights on, I can just copy this hex value and I can paste it right into here. Now let me I think I still have this in my clipboard here. So let me paste that here. So then I can enter this hex value into the area provided and click Write, and then this will actually turn on my LED strip. Pretty cool stuff. And then we also have some user descriptors, and we've got a notify property here. When I scan everything and parse the services, I go ahead and I enable all of the notifications and indications. So here on this notify characteristic, I can see that notifications are in fact enabled. And if I wanted to, I could also disable those, but I'm not going to disable them now. And then there's one other cool thing I wanted to show you. This is my fitness watch here, which is Bluetooth enabled. So let me go ahead and click on this one. And again, we have the same thing. We've got the device name, whether or not it's connected. And here we have our generic access service, and I can read from this. For appearance, they're not advertising anything important. Again, this is really cool. Here's another example of how each characteristic can be parsed differently. So for the peripheral preferred connection parameters, I can read from this, and I can actually get the connection interval in milliseconds, the latency, and the timeout multiplier. And I'll show you how I'm doing all of that in Android Studio when I go through the code. So let me click through here. So here we have a service changed, indicate. And I can go ahead and click here and say that indications are enabled. And I'll show you these in action in a second. So here, for their manufacturer services, we've got a couple different characteristics here. This middle one is the coolest one. And let me show you how this works. So if I actually hit my fitness watch, there we go. All I did was I ended a workout, and now I can see that a notification was enabled from the device, and I get the notification right on my phone. So that's pretty cool stuff right there. That's pretty much it for my recent UI changes. Now let's head to the database and see what tables that I've added. Now I'm here in DB Browser for SQLite, and I've added 2 tables since my previous videos. And if you haven't seen them, make sure to check it out to see how we've gotten to this point so far. So in this round, I've added characteristics, and I've also added descriptors. And this allows me to pull the data from my repository. So if we browse the data, we can see these are all the characteristics. And then these are the descriptors. As you can see, here's our very important one to enable notifications and indications. So that's pretty much it. Again, I'm pulling this data from Nordic's Bluetooth numbers database. You can find that on GitHub. And I have a link to that in my first BLE video if you want to check that out. And that's pretty much it for the database changes. Now it's time for the new code. First, I'll briefly go over my data layer. So here in my BLE models, I've got the companies, the services, and then here's the new characteristics. I've set the primary key to identifier on this one. And then for descriptors down here, we've got the identifier, the name, the source, and the primary key is on the UUID. So pretty basic stuff here in my DAO. I've just added what I needed to pull the characteristics from the UUID and also to pull the descriptors. And the repository looks very similar. We get the descriptor by UUID, and we get the characteristics here by UUID. Next, I'll go over my view model. It's changed quite a bit since the last video. So let's go into presentation, scan, and we'll go into the scan view model. Here I'm collecting from several different flows. First, we have the devices, which is the list of scan devices that displays on the home page. And then we have the selected device. This is actually the device that you click on from the home page. And next, there's a BLE message, which comes from the BLE Gatt service. And this is basically an enum class for the connection state, and we can be connected, connecting, disconnecting, or disconnected. So back to the view model here. We also have a user message that shows in a snack bar in the UI. And then finally, we have device details, which comes from BLE Gatt. And this is going to be the services, characteristics, and descriptors. Next, I combine my flow, and I check to see if the selected device is not null. And if it's not, I create a device detail with the scan device and device details that are pulling from my Bluetooth manager services that I have running. So I create my view model state here, and then I share it to my UI. Now here I have a couple different functions. You can start the scan, you can stop the scan. Here we have on connect. This is one of the new functions, and this is what's called when you actually click on a device from the home page. So what it's going to do first is check the list and get the device address, the MAC address. And once that's found, it creates a device detail and sets the device, the selected device in the flow. And for now, the device details is going to be an empty list. We stop the scan and then call BLEGatt.connect with the address. And I'll show you how that works in a minute, but first I just want to go through the view model and give a higher level demo of how everything's working for the user interface. So we've got this function to read a characteristic, and it passes the UUID. And then we can read the descriptor. So these are being called when you click the read button from the UI. And here's the write descriptor function. This takes a few more parameters. You need the characteristic UUID, the descriptor UUID, and then the hex string that you'd like to write. And it goes through and calls BLE Gatt write descriptor. On back from device, this is when you just click the back button from the device detail. Then we have a disconnect function. And then we can also write to a characteristic. So it gets the characteristic UUID and the bytes that are going to be written. And this comes in as a hex string. And then the hex string is actually decoded into bytes. And I have a ton of utility functions here. So I might as well go ahead and show that now. So you may have seen this in my previous video. I've made a few additions to it. We have byte array to hex, byte array print, which actually just prints out the actual byte array with brackets around it. And then we have an integer to hex. And then we have bits to hex. This is when you actually have to read the bits of the byte array. For example, for the appearance, we had to read the bits for the category and the subcategory. So this is more bits functions. And then we have byte array to binary string. This is how I'm actually printing out the ones and zeros for the binary string. To binary, long array to hex. This is for when I'm using bit sets and I convert them to a long array. We've got string decode hex. So we go through the hex array and turn it into a byte array. And this decode skip unreadable, this is when it actually tries, say we're reading the device, then this goes through the byte array and converts it to a string. So this is when we could actually get the device name. And then I've already gone over these. So tons of utility functions here. If you have time, go ahead and go through and check them all out. So back to our view model here. So we've written a characteristic, show user message. This just prints out the snack bar and user message shown. It sets the flow to null. So that's pretty much how the view model is working. Now let's get into a more detailed view of what's going on behind the scenes. So here's my BLE Gatt service. And this is taking in a ton of constructors, and most of these are my use cases. I found use cases to be extremely helpful for this instance because it just isolates all the code and allows me to parse all of the services, characteristics, and descriptors. So here I'm setting the Gatt to null at first because we don't have a Gatt instance until we actually connect to a device. And then here's the Bluetooth adapter, which I'm getting from Coin. And then here's my connect message. This is a flow. And again, this is that enum that I showed you before of whether or not it's connected. And these are the device details. This is what's actually coming back once we read the device and discover the services. So here's my Bluetooth Gatt callback. And this is a huge object here, and I'll show you what I'm overriding. So first we override on connection state. And this, when you actually click on the device from the home screen, this is going to tell me what state it's in. So I can see if it's connecting, connected, or disconnecting, and then I can create a flow for this and let the user know right away what's going on the front end. On services discovered, when a service is discovered, it calls my use case. So let me show you how these work here. So I'll go to my domain and I've got a package for use cases. So Parse service. This takes in the repository, and that's my room database on the back end. And we call invoke and we get the Bluetooth Gatt. So here it loops through all of the services that are found. And first thing we do is from my room database, I can get the service name. And if it's null, then I just call it manufacturer service. And then I create a service data class. Next, I want to loop through all of the characteristics. So this is pretty cool. Here I loop through permissions, property, and write types. And let me take a little detour here and show you how that works. So I've got in my models, I set up a couple things to make life a little bit easier. And let me see, I've got these, is it in here? Yeah, Bluetooth constants. So I set up some default constants. And I've actually defined the permissions as an enum class. Even though these are already defined in some of the Bluetooth APIs, I just thought it was easier to kind of reproduce this and create enums. That way I can easily search through my data classes and figure out what permissions and properties are enabled. So I go ahead and set this up, and this mirrors the Bluetooth API. And then I create a companion object. So back here in my parse service use case, we have characteristic.permissions. And this is a bit mask that we need to parse and see what kind of permissions are enabled for this characteristic. So back in my constants, get all permissions, I take the bit mask as an int, and then I loop through each of my enum values and I perform a bit mask operator and to see if it exists. And if it's greater than 0, it does. So I go ahead and I add it to a property list. and that's just a mutable list of BLE permissions. And back in my use case, it does the same thing for properties and write types. So we can go through here. So we've got write types, and we've got the properties. And again, it's just doing the same thing. It's doing the bit operator to see which properties are enabled. Then back in my use case, next we get the descriptors for each characteristic. So again, it loops through here and checks the descriptors. It checks my room database and gets the descriptor name based on the UUID. And it sets everything up here. We're setting the name, the characteristic UUID, the permissions, the notification properties. And then the read bytes are going to be null until we've actually read some bytes from the descriptor. So finally, it adds the descriptors to the characteristic. And then finally down here, we're combining all of these services, characteristics, and descriptors. Next, there's onCharacteristicRead, and that's when you actually click the read button from the UI. And what happens when that comes in, again, it's going to call another use case, and it's going to pass the characteristic bytes that come back. So let's go ahead into that use case, read. So what this is doing is I'm not interacting with room at all for this. This is creating a list in memory, and it basically loops through the existing list of all these services and characteristics. So if the characteristic matches what comes back from the callback, then we go ahead and update the bytes. And let me show you what this looks like. This is my device characteristics data class, and this is populated from the Discover Services callback. So here we've got the UUID, the name, which I get from my room database backend, and then here's the list of properties, which is the enum that I showed you earlier, the write types, and the list of descriptors. And then here I tried to keep my data classes really light. Even though it was tempting to put all the functions inside them, I wanted to keep them separate. So what I did was I created a bunch of extension functions. So here's update bytes. So it gets the bytes from the callback, and it just returns the copy of the bytes that came back. And then back in my use case, it sets that up and it returns the new list with the populated bytes. So back in my BLE Gatt, my device details gets populated with everything that it needs to, and then the UI is updated from the ViewModel. And again, just as above, here's onCharacteristicRead, and notice that I have two overridden methods. One is for API 33. Google has made a bunch of changes to the API that's only available for SDK 33 and up. So I started to integrate some of that, but I haven't completed that fully. So here I have the two overrides, and as you can see, the definitions are a little bit different. This one returns the byte array, whereas the older one just returns the characteristic, and that's when you're calling .value on the characteristic. So as you can see, this is deprecated, but for now it works for the older devices. OnCharacteristic changed. This happens when a notify or indicate is triggered, and we saw that happening when I was interacting with my fitness watch. And again, I have a use case for this called Parse Notification. So this is doing something very similar. It's just going through this list, and if the characteristic matches, then it's updating the bytes. So I'll go in here real quick. So update notification, again, we're just updating the bytes and returning it back to the UI. OnDescriptorRead is very similar to CharacteristicRead. So I'll just skip through that. And again, I have a use case for that. And then finally, for the Gatt callback, I have onCharacteristicWrite and onDescriptorWrite. And currently, I'm not really doing anything with that right now for the UI. But eventually, I might just send something back to the user that the write was successful. So here I have a function that enables notifications and indications. And what I'm doing is if the Gatt has an actual device loaded up, then it's going to go through all the services and characteristics, and then it's going to find the descriptor and the CCCD UUID. And then the first thing we need to do is set the characteristic notification at the characteristic level. And then the next thing we need to do is determine, so I'm doing a bitwise operator here, and I'm checking to see if it's a notify property. And if it is, then go ahead and set the value of the descriptor and then write to the descriptor. And then I do the same here for indicate. I see if it's an indicate. And if it is, I set the indication value and I write the descriptor. And here I added a little delay. I found that when I was calling this, when the services are discovered, some of them would not be enabled. So it looks like I need to give Gatt a little breathing room and just let it sit for a minute before I enable each descriptor. And that worked really well. Once I did that, the UI populated and everything was enabled for me. And then we have connect. This is from the ViewModel. We could see that the MAC address will come in. So then the ViewModel calls this connect method with the MAC address, and then it sets it to connecting. And then we call the Bluetooth adapter get remote device from the address, and then device connect Gatt. So this is going to initialize that Gatt callback where we've defined all those use cases. And then these are called from the ViewModel. So we have read characteristic, and it just loops through the Bluetooth Gatt services and characteristics, figures out what you'd like to read from, and then goes ahead and calls this. And then again, this would trigger the callback. Same thing for read descriptor. And for write bytes, this passes the byte array. So it comes from the UI to the ViewModel to the Gatt service, and it passes the bytes that you'd like to write. So here you can see I'm doing the check. If the SDK is greater than tiramisu, then go ahead and call this. Otherwise, call the old deprecated method. And then we have write descriptor, and finally we have close. And close just cleans everything up. It sets the state to disconnected, it empties out the flows, and then it finally closes the Gatt service. I won't get into too much detail for the compose code, but let me just give you a quick overview of how everything works. So in my presentation layer, in the home composable, this is kind of like the top level composable that sets everything up. So I'm getting my state from my ViewModel, and then I'm checking some permissions, and I'm checking to see whether the user message is not null. And if it's not, then I go ahead and show a snack bar in the UI. And then I'm setting up my scaffold. So basically, if everything is good, if permissions are good, then it checks for two things. Basically, are we looking for the home page, or is a selected device actually not null? And do we need to show the device? So as you can see, this composable takes a ton of functions, and these are all of our primary function calls. So connect, disconnect, go back, read the characteristic, show the user message, write to the characteristic, read the descriptor, and write the descriptor. So let me show you this composable real quick. Let's not see the preview here. So basically here we are, we're taking in all of the functions, and this goes through, this is the top app bar. And then I'm going through, and this is the connected. So it's basically checking the current state. So this is all coming from the flow, and the user is updated as the Gatt service pushes different notifications to the user. I'm showing my connection status here. And then we get into device details, which is just the manufacturer name, if it's available, the MAC address, things like that. And then finally, this is really cool. This is the service pager, and that's what's actually listing all of the services and characteristics underneath it. And you can toggle back and forth through each service. So let me show you how that works real quick. So we've got a selected device, and we've got a list of services here. So it's remembering a couple key states for the arrows back and forth. And it's creating, so this is creating go back from a service here, and this is saying move forward to the next service here. So it's just a custom pager that's moving back and forth through the services. And then we have the detail down here. And the detail is what actually shows the characteristics and descriptors. So we go through, and this is just an outline card. And again, we're saving the states and whether or not menus are expanded. So we've got that read-write menu that needs to be toggled back and forth for each characteristic and each descriptor. So it's tracking that state. So here we have the characteristic name, the UUID, the characteristic properties. This is my read and write menu here. So this gives you the drop down of whether or not you want to read or write to a characteristic. And then here, depending on whether you've selected read or write, I show two different composables, either read characteristic or write characteristic. So for the read characteristic, we've got some assist chips, and this is basically to read from the device. And then we're calling the ViewModel. Once that's clicked, you can copy it. You can copy the read data that comes back. Down here is the box that displays the information that comes back from the actual device. So I want users to be able to long press and copy this information. To do that, I use selection container. And once you encapsulate everything in there, users can go ahead and long press and select the text from their Android device. So here I call get read info, and let me show you what's going on here. As I mentioned before in the demo, each characteristic can have a different way to parse all of the bytes. So I tried to handle this in a very organized way. Now here, we're getting the read bytes, which comes back from the device as a byte array. Now, depending on what type of characteristic this is, I may want to parse this in a different way. So when the UUID matches this appearance, then I want to use appearance, get read string from bytes. And let me show you how this works real quick. So back in my domain layer, I have a package called BLE Parsables. And this sets up an abstract class. So we've got a parsable UUID that takes the UUID as the string. And we have a couple functions that can be the same for each characteristic and for each descriptor. So we've got a commands that returns an array list. And we've got get read string from bytes, which takes the byte array that comes back from the device from the Bluetooth Gatt callback. So let's look at the appearance class real quick. So this appearance inherits from parsable UUID and sets the appearance characteristic. And now we've overridden the commands function. In this case, it doesn't have any commands, and I'll show you how that works in a second if we actually do have commands. But then get read string from bytes. So for the appearance, what we need to do is, per the Bluetooth specification, we need to read the bits, and bits 15 through 6 is the category, and 5 through 0 is the subcategory, and the value is the actual value like gamepad or watch, whatever it may be. So to do this, I can define how I want to parse these bytes. So first I get the bits, and I'm using my convenience functions here to get the bits. Then from these bits, I call substrings, and I'm converting them to hex per the specification. So then I return the bits, the categories, and the value as hex strings, and that all comes back to the user. So if we go back to our characteristic here, there can be other ones too. We have the preferred connection parameters, and that was returning the latency, the timeout, and the connection milliseconds. So let's see what that looks like. We'll go preferred connection parameters. And again, the commands are empty here. So as you can see here, for preferred connection parameters, the get read string from bytes is completely different from appearance. And I won't go into too much detail how this works, but basically each value is chunked into 2 bytes from the byte array. So you combine the 2 bytes together to get your values. I could have done some bit shifting here, and I have this in my comments if you want to check it out. But I really like using bit sets because they kind of handle everything for you. It's less code, and they seem really convenient. I've had a lot of luck using them, and I think I will continue to use them until I find a reason not to. So this just basically loops through the byte array, and it takes chunks of 2 basically throughout the byte array. And as it goes through, it calculates my connection intervals, and we need to times this to get the milliseconds. And then I use my bit set to get the latency and the timeout multiplier. So basically, I'm using a completely different function to parse these bytes that come back for this particular characteristic. And now let me show you what commands look like real quick. Actually, it's better if I show you this. So for notifications and indications, we kind of know, we can hint to the user what they need to write to this descriptor. We know they either need to turn notifications on or off. So for commands, I'm giving them hints. And basically, I can say, here's the hex string that you need to enable notifications or disable them. And I can pass my parameter in, and in this case, it's BLE properties. So it can be property notify or property indicate. And if it's indicate, then it'll show these hints. And this is all coming from the composable. So if we remember back here, we call characteristic.getReadInfo. And then that getReadInfo is looping through all of these classes and determining how to read the specific characteristic or descriptor, because it works the same way pretty much for descriptors as well. Back in my service pager, so that was read characteristics, and users can also write to a characteristic. So let's look at that composable real quick. So here we're setting up some states to track the text that they're entering in. And then here, this is what I was just showing you. So for the command hints, it checks, it says get right commands from the characteristic. So here's get right commands, and these are all the classes that I was showing you. So if it matches a UUID and we have a custom way to parse the characteristic, then it'll go ahead and print this back to the composable and let the user know, hey, here's a couple hints. If you want to use this particular one, then they can just, again, here I'm using selection container, so they can actually copy this text and write it to the device. And then here, this is just an outline text field, and it gets the text to write. And in the end, after it writes it and it sends it to the ViewModel and then to the Bluetooth Gatt, it lets the user know that it wrote this hex value at this timestamp. That's pretty much it for my recent updates. There's still a ton of work to do, but it's definitely getting there. I know I went through things pretty quick, so feel free to check out the source code. It's all out on GitHub, and thanks for watching.